Hey everyone, Darren Eastman here, Principal Product Manager for Runner. I'm joined by the esteemed Thomas Masukin, Senior Engineer for Runner, who's been with Runner for at least 6 years now, Thomas, or 7 years?
Will be 8 in
8.
December.
So Thomas is like one of the original architects of all of the great things in Runner. And today we're talking about metrics, and specifically metrics endpoints in Runner. It's a question I get all the time with customers is, okay, customers typically say, hey, Darren, I know you're building a bunch of like new things in the GitLab UI, kind of related to observability and runners, but like what's available today? And typically when customers ask me that, I say, well, if you look at our docs, we've got this Prometheus metrics endpoints that we expose on a runner, and you can do all these great things with it in terms of monitoring. And let me just share my screen. And that's typically the extent of my answer, because I actually haven't done a whole lot of work myself in doing some of this. So very recently, Tomas actually added some new metrics. Hopefully the screen is showing up. And he's calling the queue duration histogram metric. And he was sharing this in Slack, and he was sharing some really great graphs. So I felt it'd be a great opportunity for us to like chat with Thomas, talk about what this new thing is, kind of the benefits, and maybe Thomas can kind of walk us through for us who are less inclined, like how you go from understanding there's a Prometheus metric endpoint on the runner to creating some of the really cool graphical dashboards that Thomas uses to manage his. You want us to get that back on. So Thomas, I'll stop sharing and like pass it over to you.
Okay, thank you. So you are opening here a huge can of what can be done and how to be done.
I try.
Because we have here both things that are really, really easy, and we have things that are complex, especially if you are new to Prometheus and monitoring in that way. Let's start maybe from the basics. Let me share my screen, and I think this is the one I want to use. Yes.
Wow.
So can you see the console? I think you can see the console.
Yeah, I can. You've got all kinds of really cool things going on with GitLab, Tanuki images on top of the world map. It's awesome.
Yeah, so the simplest way, the simplest thing is to enable the metrics endpoint in the runner, because when you look on the config toml file, this is the only thing you need to add: a global setting listen address with the address to which you want to bind. So basically this means 0.9402 on any possible interface on, this will be on my laptop. The endpoint is of course accessible through TCP. So if we can close the configuration right now. If I start a runner from that setting, you can see here information that metrics are listening. We can forget about that output. There will be nothing interesting for us for now. What we are interested in is how to read that.
Yeah.
And fortunately, with the way how Prometheus originally decided to go with metrics, it's a simple HTTP GET request to a web server that now is started on that listen address we defined. So when I do that request, I get a list of metrics with the values current for the moment where I did that call.
Right.
By the way, I think that format of the output is now an open format by itself. It's still used by Prometheus, but I think it like evolves to an CNCF maintain format for metrics. Anyway, this is what we have in the runner, and when you scroll through that, there is a lot of information. Some of the metrics are metrics like very general, because we have few what is named in Prometheus world collectors. A collector is something inside of the process that like collects data that can be next exported through the metrics. So you can see here some metrics named process something something. This is one of the collectors available in the Prometheus SDK for Golang that you can just hook up and get some basic informations about the process. So for example, how many file descriptor the runner process is using right now. There is another general collector for Go specific metrics. This is again coming from the Prometheus SDK for Golang. It's able to hook into Go runtime and provide you some information about what's happening with your process, like the number of Go routines, things like that. To be honest, I don't remember when was the last time I had to worry about any of these Go specific metrics. I think from this let's name it default metrics, the one that we've been observing a lot was the number of open file descriptors, because this is usually a limited resource on the server. Usually by default has very small limits, and with the way how runner works, how many files it creates, for example, any network connection in Unix is a file descriptor, but also runner when handles jobs is storing a temporary file with a buffer of the log output. So by handling hundreds or thousands of networking connections and thousands of jobs at once, we are creating a huge number of file descriptors. And like on SaaS runners, it was very, very long time ago when we discovered that the default limit that is usually set for the process is way too small.
Interesting.
And we had to increase that. So from this many default general metrics, I think the process OpenFDs was the one that I was looking at the most times, because we had few cases when something went wrong and exceeding the OpenFD's limit had caused an incident. So yes, that metric was definitely observed by us. The most interesting ones, and I think the ones that customers are mostly interested in, the customers users, are the metrics we created ourselves that describe internals of how runner works. So this will be kind of the business metrics, of the business logic that that you as an owner of the runner want to look on to understand what's happening with your runner and whether your settings are what you would like to have. And here at the very top, I'm sorry, this is a different Q. Maybe let's grab it. I think I have locally an older version compiled that doesn't have these new metrics, so I may need to recompile the runner. Anyway, we have a list of metrics, and for now we don't have any documentation for what exactly metrics we are exporting, because that changes in time. And in the past, initially we had that, but that documentation was very quickly outdated.
That's right. Yep. I remember that.
But the way how Prometheus SDK works is it forces you to give every metric a description. And there are a few types of metrics. So what you can do, for example, is if you are learning that, if you are new to this, you can look for just help and type information. So for example, you can see that there is a metric named, let's say, GitLab Runner Concurrent, which is a gauge. And you can see the description is the current value of concurrent setting. So in the config.toml file, you have the setting name concurrent. It's one of the default settings and one of the few that are required. It needs to be higher, one or more, for the runner to even start. And it describes you how many jobs, how many concurrent jobs in total a runner process started from that configuration file can handle. So it defines a capacity of your runner. And there you have also a GitLab runner limit metric, which is also a gauge. And you see the description is the current value of concurrent. And I see I need to update that line because it's definitely copied and that is not the right.
Exactly.
Yeah, this is the limit is the limit setting, because the concurrent one is for the whole process. It's required. Then you can have few workers in that config.tom file, and on the worker you may set a limit, so that metric will then be provided for every worker. And we have GitLab runner jobs, which is also a gauge, which shows you the current number of running jobs, of running builds. So one of the simplest and most probably informative things that you can do. And let me open a Prometheus Query Explorer. It's to find out what's your saturation. Like you have a runner, you run some jobs, you set some concurrent. The thing that you would definitely like to know is whether it's enough or not, whether I'm using all of that capacity, or maybe the concurrent is too much. Maybe I can save some money and limit it a little. So what you can do is take a simplest proportion. So we have the GitLab runner jobs metric and divide that by GitLab runner concurrent.
Oh, so this is where the magic happens. So you're actually doing a bit of a formula here to get the view that you want.
So how many jobs per how maximum can it be? And if what we usually want to do here is also limit a little the output. I don't want to go too deep into how Prometheus works, because this would be a totally separate learning course. And for anyone who wants to work with that, going through Prometheus documentation, understanding how it works, understanding the concept of how Prometheus gathers metrics and how stores them is important. Like without that, all of that will be a magic that is confusing. A lot of that will be something very, very unclear. This is because Prometheus stores all metrics as multi-dimensional time series. And
multi-dimensional time series, which is super interesting. What does that mean in layman's terms?
If we look on this GitLab runner jobs metric only, let's see what it outputs. So you can see here the help information, you can see the information about type, and you can see there is a name of a metric, there are some strange things between brackets, and there is the number at the very end. This is the name of the metric. This is a value of the metric. My runner was started, but it doesn't execute any jobs right now. So the value of the jobs metric is 0. But here we have what in Prometheus world is named labels. So every metric can be labeled by one or more labels. Every label can have one or more values. And this is what creates the dimensions. If I would now execute here like hundreds of jobs on that runner, this line here would be repeated multiple times.
I see, with different values.
It would have multiple values and different values for the metrics. Let's say that I have only one worker there, so all of them would have the same runner and system ID label, because this would be in this specific case, this would be static. But then stage, state, executor stage, these are labels showing us at what moment of execution the job is. because the job on the runner can be preparing, can be in execution, can be in turning down. I think this is where the stage comes in. Then different executors may do a few more things with a job. So again, the jobs can be on different places in the executor. And stage or state, one of these is about what we started calling some time ago steps in the CI job. So
Right.
preparation, getting sources, downloading cache, downloading artifacts, etc., etc. With that, we are able then to do few things. So the simplest one, let's sum that by the instance label. This is one of the default labels that Prometheus adds by itself when scraping the metric from the target. And why
Sounds
I
like
don't
that code is getting worse. Sorry.
It's in fact it's going down, but I still have some cough.
Sorry,
Why
folks.
hasn't
This is what happens when you do live TV.
yeah, why I don't have okay, maybe let's go to Prometheus directly. Maybe there is something odd happening with Thanos. So GitLab Runner jobs, let's go quickly through that. Yeah, we have a lot of data, so we can work on that. So let's go to our previous query. So this is a and now I remember why. This is because of the multi dimensions and the labels that we need to include, because the
I see.
concurrent
Mhm.
metric is from the global level, so it's not labeled with the label named runner, because it's not
Oh, the top level in the config.
it's not level specific to the specific runner worker. It's a global value. Maybe it will be easier if we will go sum by. I'm sorry, I'm uh
Oh, this is great.
oh, here we
This
have
is
it.
awesome to see.
Okay, so instance is one of the labels that Prometheus adds by itself when scraping the metric. It scrapes it from some remote target, and then that remote target, so it's IP or FQDN, depends on how you configure Prometheus, and the port
So
is
Thomas, really
taken into
fast. So
that.
sorry. So in this particular case, the label instance is a Prometheus generated label. It has nothing to do
Yes.
with our Git. Okay, got it.
Yes. So when Prometheus reads that metric, you can see that it has already few labels.
Yeah.
And our Prometheus is reading a metric, from example, from a remote machine that's named Runners Manager Private Blue 1, blah, 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 port 9402. So it creates an instance equal to that value label and just add it here at the end, and then stores that locally in a very, very magical way, how Prometheus stores the data. So that it can then use any of that labels to do querying, to do aggregation, which allows us to do something. So for example, first random thing, you can see that on this specific runner instance, the usage is at the level of 51%, because in this case we will get percents.
Yes.
We can like multiply that by 100, and you can see that it's like 48% here. Usually you don't do that because when working with this output, more or less you know what you want to get. If we are working with Grafana, which will be another thing in a moment, then Grafana is able to get these raw outputs. You tell Grafana what type of data it is, and it's then adding the specific unit handling by itself. So
I see. Brilliant.
So with this simple query, we can see how many jobs are executed on every runner by how many jobs can be executed on that runner. So we get the concurrency, the saturation value in the scope of the concurrent setting. So how much the full possible capacity of that runner is already used. And and this allows us to do a lot of magic. Now, what exactly we can do, it all depends on what metrics you are looking on, and you need to know what the metrics are about. And this is something that is hard to explain because many metrics are very, very low level things. For me, it's very obvious what they are about, how to understand them, because I know in the core how Runner works. I understand the internal logic, the mechanisms that we have, so I know exactly what this metric means. For some, for people who don't like do engineering, don't contribute to the runner, they just use the runner for their work. Some things may be a little harder. So this is an opportunity for us to maybe start explaining something more what we can do with the metrics, or we could start sharing some Grafana dashboards where you don't need to understand the metrics, but rather you have a dashboard that explains what you can read from it.
Right.
So something to consider for the future. Anyway, we have multiple metrics. If you go through Prometheus documentation, you will see that there are three main types. It's a gauge, so a value that represents the current value of something. It goes up and down all the time. You have a counter. Counter is a value that is only increased in time. Counters may be restarted to zero. For example, when runner process is restarted, or when the maximum allowed number by the type. All metrics in Prometheus SDK for Go are using float 64. So whatever is the maximum value for float 64 will also be the maximum value for the counter before it's restarted to zero. But Prometheus, when dealing with that metrics, is able to handle the restarts. So counter, you can understand it as a metric that always goes up. And what's the difference? Gauge is a good way to show us things when we want to know what's the correct number at this moment. For example, this value of jobs, how many jobs we have right now. Now we have like 5 of them. In 5 minutes, maybe it will be 50. In another 5 minutes, it will be 1. This will be going up and down all the time. And we would like to be able at any point in time to see how much it is. But we also have a metric named
So if I were building a metric like the total number of jobs ever executed on that runner, I would use a counter.
Yeah, we have that metric. I think it's showing up for the first time after the first job will be taken. So each time when a runner starts a job, it increases a counter of jobs that were ever started. So we can see how many jobs we had at any moment, but we can also see a ratio of how many jobs we are increasing in time. Counters are very good to handle tracking of events that are happening in times. Gauges are good to handle tracking of what's the current state of something. And there is also one last type, which is a histogram. And the histogram allows us to define buckets of numbers and put readings into that bucket. So we can then, using Prometheus and or Grafana magic, we can do some readings, like, for example, the metric you started our call with, the new Q duration metric. So it seems I've compiled runner locally before that change. So let's maybe go quickly to the code and the description of that metric.
And while Thomas is doing that, just to, again, to reframe it for everyone that might be looking at this video. So remember, we're talking about the Prometheus metrics endpoint on a runner. So if you have 10 runners, you will have 10 Prometheus metrics endpoints to work with.
Yes, exactly. Okay, so we have a metric named GitLab Runner Job Queue Duration Seconds. This is a new addition, but it provides very important information to the runner user. When you create a job in GitLab CI, it's going through several states. First state is created. When you create a pipeline, all jobs in that pipeline are created instantaneously. And then, depending on how the pipeline is processed, jobs are being slowly transitioned from a created state to a pending state. A pending state means that this job, given any circumstances that control that, is now ready to be started. So we transition, like GitLab transitions that to the pending state, and then that job awaits for the runner to pick it up. As I always repeat, it's important to remember that it's runner that asks for jobs. So runner calls GitLab and says, hey, do you have any job for me? GitLab then does a lot of magic, which we will not cover in this call. And finally gets with one of three most popular responses. One is, no, I don't have any jobs for you. 204. Second one is, yes, I have a job, 202. And with that response, GitLab sends back the JSON payload with all of the details. So runner can start executing it. And the last most popular response is 49 conflict, which means that we probably have too much requests at that moment. Please repeat again. Because for some reason, we've been not able to find you a job or decide that you don't have a job to execute. So please repeat. Anyway, depending on how you configure the job, how your project is configured, how many runners of different types and configurations you have available, the specific pending job that you're looking on may be finally executed by only one runner of dozens available, or may be executed by any of them. I can tell that. It depends on a very specific configuration of your case. But let's simplify that thing. Let's say I have my own GitLab instance. On that GitLab instance, on the whole GitLab instance, I have one runner, nothing more. This runner is configured to take any possible job, no matter any tagging, not tagging, things like that. Any job that is in the queue, the runner can take it. And let's say that I created a few jobs, and now I see that it's 2 minutes later, and the job is still in the pending state. It was in the pending state 2 minutes ago. It's still in a pending state. What it means? It means that the single runner I have didn't ask for that job. And from our experience and from talking with many customers and community members, the speed of taking jobs from the pending queue is probably one of the most important factors when it goes for runner user experience. People like on GitLab.com, on our SaaS runners, people expect that the job will be taken from the pending state when the job is targeting one of our SaaS runners, that it will be handled and taken from the pending queue in a matter of seconds, maybe a few minutes. But when that goes beyond 10 minutes, 20 minutes, an hour, for most of the users, this is something that they can't accept. And now, from my point of view, as a person who manages these runners, this means that tracking that timing is something that is important for me, because I can like track, I was able right now to track multiple different metrics. I was able to know how's the auto scaling of the runner behaving, what's the usage of the runner host resources, the file descriptors we talked about. All of that I was able to observe, fine tune, notice that we are like reaching maybe some capacity, so maybe we need to reconfigure something. But knowing whether the runners pick jobs in an acceptable time was hard, because we didn't have that information on the runner side. We had that information for a few years on the GitLab side. That on the GitLab side, this has two problems. First, we don't provide these metrics to our customers on GitLab.com. And if you're a self-hosted GitLab administrator, you may also like provide that instance to users who not necessarily would like to give the metrics of the system to. So access to that metric is already limited. If, for example, someone self-hosts runners for GitLab.com projects, no way to find out whether runner picks jobs as fast as we would like to. The second problem is that on the GitLab side, we are labeling the metric with the duration was counted for the instance runner or not. Nothing else. We can't track that per project. We can't track that per group. We can't track that per runner, because that would create a label cardinality that Prometheus don't really like. And that is a good way to kill a Prometheus server very quickly. Like give it hundreds of metrics with like thousands of small amount different values of a label. Because for every label value pair for a metric, Prometheus is storing the metric as a separate time series, and then it's using like a lot of compute magic to like do disaggregations, allow you to like quickly access these metrics. And now, if you, for example, this is one of the things we've been often asked, and we also always need, unfortunately, to decline. Hey, there is this metric on GitLab. Could you like label it with the job ID, because I would like to track something per job? No, we can't, because a job is like, this will be too big cardinality. You will quickly get hundreds, thousands, maybe even millions jobs. Like on GitLab.com, we are handling few million jobs every week. And each of the job would force Prometheus to create a separate time series stored in the storage, and then every query would need to like gather all of these millions of time series to like compute the data together. If you work with so big cardinality of the label values, we learned that hard way. It kills Prometheus very quickly. This is why in GitLab we in fact have some policies and checks about what metrics we are adding, what labels they have, how many labels they have. Basically, I think at this moment we are declining adding a metric that would have more than 10 labels by itself, because there are also a few more that Prometheus will add. And especially if that metric is going to be tracked by GitLab.com monitoring. So this is a problem on GitLab.com, like on the GitLab instance. We have a very, very small understanding on when the jobs are. We know only what's the histogram of queue duration, but for instance runners or for non-instance runners. And then we can give that information to the users. And even for us, this was a big limitation. Now, since GitLab 16.4, this is a feature that will be released in GitLab and GitLab Runner 16.4. That metric will be also given to the runner. So when the job is scheduled to the runner, when the runner asks for a job, GitLab finds a job, assigns that to this runner, and sends back the job payload. One of the new information in the job payload is the value of queuing time. So we send to the runner information about all details of how the job should be executed. And hey, your job was in the pending queue for 5 seconds or 10 seconds or 12 hours. Yes, it happens. And now for us, speaking as a runner owner for the SaaS runners, I'm now able to track that queuing time for every single runner that we have. So let's get back to, I'll copy this information. Let's get back to our Prometheus. And let's for now, don't do any magic here, but sum by shard. Shard is our way how we label things on our infrastructure. This is not a label that is automatically added. So for anyone else, this query will probably not work. You could use here instance. Let's do instance. Let's do instance for a moment. And why it doesn't work?
Live TV.
This is what happens when you do such things live. Oh yeah. Because this is a metric name, but histogram creates like when you define a histogram metric like here, it's named like that. But because if it's a histogram, it will create 3 different metrics. There will be sum, then will be count, and then will be bucket.
And so, Thomas, before you jump off the screen, if you could go back to that screen for a quick second. For folks, just a quick context, I don't think we mentioned this, or maybe Thomas mentioned this. The screen that Thomas is looking at right now, I believe, is the runner code base, and he's looking at the actual runner code itself.
Yes, it's in GitLab Runner commands buildshelper.go, if anyone would like to look at that. So if we execute here, it will give us some information. Let's do this for now by instance and LE. LE is something specific to the histogram bucket. LE defines the bucket value. So if you have like 2 or 3 instances of runners, doing this by instance will probably work. In my case, I'm not interested usually in a single runner manager. I'm interested in group of runner managers, and we name these groups as shards.
So now here a bunch of instances. Okay.
Yeah. So now here, what I can do is I can see some information about every separate shard. So previously, taking metrics from GitLab, I could only know how good behave all instance runners that we provide. And we have like, currently we have 7, 8 different shards of instance runners for 3 different platforms. And each of that platform has different needs. For example, Linux runners, these are generally available. These are our most mature ones, and these have very, very fine-tuned SLI and SLO. So anything going wrong will be very quickly alerted. On the other hand, Windows and Mac OS, these are still in beta. We are still experimenting with them, learning how to tune them to like fit best what we want. And while we are also interested in measuring them and providing us as good performance as we can, we expect that there may be something wrong. So we would like to, for example, have lower alerting thresholds or higher alerting thresholds, depending how you look on that. Previously, I couldn't diverge that. It was all hidden in one bucket. This was for instance or non-instance runner. Here, I can track that for every specific shard. So I can now define alerting based on whether we meet our acceptance criteria for how long job is in the queue, differently for different SaaS Linux runners, differently for the macOS, and differently for the Windows runners.
Hey, and quick note, I just want to jump in here for customers that will be looking at this video. Just a quick note, and I'm sure it's pretty obvious, but I'm just going to call it out. On GitLab.com, these are all instance level or shared runners. I know for some of my customers, you have a mixed environment. You are offering some instance runners. You're offering runners at a group level. In some cases, you're allowing the group owners to offer their own runners. So again, if you have a large runner fleet, if you like GitLab and you're doing tens of thousands of jobs per month across a mixed fleet, and you're thinking about how to do something like this, you have to kind of think about, okay, maybe start with my instance runners first, and kind of think methodically about how you might want to implement monitoring, especially if you have a kind of a disparate fleet. Thanks, Thomas.
Yeah,
back to you.
And the good thing with this new metrics added in 16.4 is that now if you are a runner owner on GitLab.com group runner or project runner or self-hosted GitLab instance group or project runner, you are now able to track these metrics and you are now able to analyze whether your runners are picking jobs as fast as you want them, as fast as you think they are picking jobs. This is one funny PromQL query. So what we do, we are getting this bucket metric for every single entry. An entry here will be this metric with all of the permutations of label value pairs. We are calculating a ratio in the past 5 minutes because this bucket metric is a counter. Then we are summing that by shard because I want to know about shards. We are summing that by LE, so the bucket value. And then there is a Prometheus function named histogram quantile. And this now says me that on our private runners, 90% of jobs are handled from the pending queue in less than 7.8 seconds. On our most popular SaaS Linux small, where is SaaS Linux small? Oh, SaaS Linux small was not yet updated to that version, so we will not see it here. But let's say SaaS Linux medium.
98%,
90%, because it's the 19th percentile. 90% of jobs were taken from the pending queue below 0.98 seconds. If you look at 50th percentile, so a mean, so half of jobs that finally land on the medium runners are queued for no more than 0.54 seconds. So in less than a second. And now we are able to like analyze that per the shard, per instance, per whatever other grouping definition we will define for ourselves, and we will like to say, hey, this is a virtual group that we like want it to have a specific SLI, SLO, and if like, for example, the small runners that we have here, our current objective is set to also like look on the fair scheduling algorithm. Again, not something that I would like to go deep into.
I agree. That's a question I want today.
Yeah, but like for specific cases of jobs that are finally landing on the small runners, we expect them to be queued for no more than a minute. If this specific types of jobs will be queued for more than a minute, we are reducing our updex score, reducing the updex score below some threshold, alerts the EOC, alerts us, it declares an incident, and we are forced to find out what's happening and how to fix this problem so that our customers don't feel that the problem is even there. And that metric is based on how long the job is in the queue, which now allows us to adjust this alerting for every single shard and the deciding where we accept bigger or lower delays.
A quick recap for the folks. Sorry, Thomas. A quick recap.
Of course.
Thomas mentioned SLI, which is, just for clarity, service level indicator. I believe he mentioned SLO, which is service level objective. And so Thomas's team had service level objectives to meet for how quickly those jobs get picked up. He mentioned AppDex, just hold the discussion another day, but basically we do alerting, or Thomas's team does alerting based on whether or not we are picking up those jobs within the SLO target or service level objective targets.
Okay, so we talked a little about what Prometheus metrics are, how we can learn something about them from the output, how you can query them from Prometheus. Now, there are two more things. First thing is that all of this magic here works when you get the metrics to Prometheus. And for that, there is no other way. You need to go through the documentation, learn how to set up Prometheus, and think how to set up Prometheus in your case. Because some people are using Kubernetes, some people are using bare metal, some people are using cloud instances with infrastructure automation, some cloud instances with everything done manual. I can't answer you what's the best thing, because you know by yourself probably how you would like to have it. Prometheus is currently a mature project, is part of the CNCF, widely used across the cloud computing industry. So at this moment, it shouldn't be hard to find tutorials and good documentation about how to set it up in any specific case that you think you are. So this is a part that I really can't hear told much, because trying to show how we set up for GitLab COM infrastructure, it would be a few hours of talking, and I'm not sure if I even know everything, especially that we are wrapping Prometheus servers with Thanos, which is like clustering mechanism and extending storaging and querying and a lot of things. I have a Prometheus server locally on my laptop, but that's probably useful for local development machines and not for someone who'd like to have it for their production. So go to Prometheus docs and learn from there. The thing is that you need to get a Prometheus server, and in this Prometheus server, you need to configure scraping of the endpoint that we configured here. So first thing, enable metrics on the runner and start the process. This is important. If you will update this config.tom file when the runner process is working, the metrics service will be not started. You need to restart the runner process. So start the runner process with the listen address in. This will create the listener. Make sure that your firewalls allow your Prometheus server to access your runner. Configure your Prometheus server to start scraping metrics from runner. And when you will have that, you can start playing with the queries like here, start experimenting with what metrics runner provides and what information we can get from there. And the last thing that users very, very often ask us about is how to go from here. So raw metrics where you need to understand how to write the query and how to analyze the graph, to this,
The magic.
where this is printed in Grafana with sometimes additional information, like here, some explanation for the graph. This one is maybe not as interesting, but let's look, for example, on runner manager, runner manager details. And all of the graphs here we have, it's all from Prometheus metrics. Most of them are taken from the runner, but we also have some metrics from GitLab. We have some metrics from GitLab Workhorse. There are a few parts of the GitLab application stack that are more or less related to GitLab CI/CD, that more or less indicate what's happening with the runners, and especially in case of problems and incidents. We track also GitLab and Workhorse and a few other places to know whether it's caused by runner or whether runner is just having problems because, I don't know, we have a database incident right now. And because all of the jobs queuing and assigning to runner is happening through SQL queries and to the database, if database is struggling, it affects all GitLab, including the runners. So we may be, for example, by this here, we may be alerted that the updates dropped, but then going through some incidents, we may find out that, okay, it dropped because we have right now a database incident. And this is not something that I can fix because I'm not a database specialist. We need to get a series and our database team involved so that they can fix the database, and that will fix many things, including runners. Here, for
Hey,
example,
Thomas,
you
yeah, can you
yes,
expand that one? Yeah, thanks. Exactly.
yeah, this is a live view of the metric we've been playing with here. So this is taking this metric and using a Grafana heat map panel type to show the timings. Below you can see the legend. So the darker the color, the smaller number of events in a bucket. The lighter the color, the bigger number. And looking at that, you can see that the majority of jobs happens here. So below 1 second. And this is for all our shards, excluding the small, because the small one doesn't provide that metric yet. But all others are providing that. So if we look on most of the SaaS runners that my team is maintaining, you can see here that in past 12 hours, the dashboard is set to show 12 hours. There was 6 jobs scheduled for more than an hour. But you have like 1 to 15 minutes occasionally. The majority of jobs is scheduled below 10 seconds. And this is what I can read from that graph. And now, given that our objective is that specific cases of jobs should be scheduled below 1 minute, and I see here that most of the jobs are scheduled below 1 minute, I now know that everything is going fine as I wanted.
And Thomas, last question on this one before you get off of it. Everything is going fine, don't agree, but for those sections of the histogram where there's a little bit of like a banding, say up to the 5 minute or maybe 15-minute mark, as you look on this graph, should you be concerned? Should a user be concerned about where those bands are hitting 5 or 15 minutes, or because the frequency or the count is so low, it's not something to worry about?
Yeah, this all depends on what are your objectives, and this is the class of question where I can't give you a straight answer, because it depends. It depends of what's your goal. It depends of what's your objective. What is your configuration? For example, we want to bring the best user experience. We learn that for the users, one of the most, I don't say the most important, but why one of the most important indicators for their happiness from usage of our platform is that their jobs are not scheduled along in the pending queue, because they may take longer or shorter time. It all depends on what you are doing there. For some people, a job executed for more than 5 minutes will be too long and they need to search why. For some people, a job executed in 3 hours will be a success. But almost all of them want the pending job to be taken within a matter of seconds. But to get that, we need to fine tune our auto scaling, our capacity. Basically, we need to throw some money, sometimes over provisioning our runners fleet, to like give it a lot of space to quickly take the jobs. But you may be a user who is fine with having these timings even much longer and waiting even an hour for a job to be taken from the pending state, because you produce like 10 jobs a week and you have one runner configured to handle only one job, and you don't want to invest more money in that CI power. You don't just require so big capacity and speed of that. And then seeing in that histogram, seeing the jumps over hour, over the infinity, for your specific case, it may be totally okay. And you may even don't care about that graph at all. You may be interested in other metrics about runners to decide whether this runner is working as you want or not. So it's not something where I can give you a magical answer that will fit all cases, because most cases will be different. But from our point of view, like the SaaS runners maintainer, I know that our users are interested in the quickest possible scheduling. So what I'm looking here is having the lowest readings. And now these occasional spikes, it's not bad. And it's definitely within the, like below this 1 minute, it's within the, I'm sorry, within the service level objective that we have. And like I said, it's not for all jobs, it's for specific jobs, given how first scheduling algorithm works. And we would like need to go a little deeper to understand why these few occasional readings below even 5 minutes, it's not a problem for me. But if we would jump to, I think it was Thursday last week, when we had an incident, Thursday or Wednesday, I think it was Wednesday. Or not. Anyway, we had an incident when our, I can see it because it was on the small runners. We had a small Linux runners chart incident. Basically, some jobs were queued even for 6 up to 8 hours because of problems that we had. And on this graph, you would see that it like goes, all of these light orangey cells are going up here, and you have like a huge orangey yellow blob like spreading across all of that panel.
Right.
And for me, knowing what's our objective, this is definitely not what I want to see here. And it was one of the metrics we've been looking on to decide whether the incident is resolved or not.
Oh, brilliant. Brilliant. Hey,
so
well,
yes.
Thomas, I'm sorry, go ahead.
This is where the most magic happens, because we occasionally are using raw Prometheus queries to like look for specific metrics, especially if we don't have yet a panel for that, or it happens so rarely that we even don't need that panel. But most of our monitoring is going through Grafana. So we have Prometheus alerts that are pinging us, and we have Grafana to get an overview of what's happening. And the big thing for the customers, the big problem for customers and users, is how to get into this Grafana dashboard. And yeah, my Firefox is failing recently, so that's not a problem of Grafana. this is again a problematic thing, because we have our dashboards created programmatically from code. We have the project is public, so I can share it here. Dashboard CI runners. So looking at this dashboard that we've been looking here, CI runners incident support runner manager. So the dashboard that you can see here with all of the panels and all of these nice colorful graphs is defined in this file, which doesn't tell you much.
Right, yeah.
Because to know what's happening here, you need to go to all of these includes. And here we are going very, very deep, because first, if you would like to look on this project of ours and analyze it and build on top of that, you need to learn Jsonnet. You need to learn the Jsonnet library for Grafana. So for example, the queue duration metric that we've been looking on, it's defined in job queue graphs duration histogram. And here you see the query we had. And is it this one? Yeah, it's this one, I think. Or maybe in job histogram, job graphs. Anyway, as you can see, there is a lot of strange code here. You would need to learn Jsonnet. You would need to learn how Prometheus work. Different panels of Grafana, etc., etc., etc. If someone wants to do it in scale, going through that hard lesson definitely will benefit. Like for us, it was a huge change when we switched from handcrafted dashboards in Grafana, because in Grafana you can go through UI, like new visualization, the heat map. Let's go to our job queue histogram. So we add the query. We need to make sure that, of course, you need to set up Grafana. You need to point it to your Prometheus. There are documentation for that, and I definitely will not explain that. We would need to throw away this, because this is part of Jsonnet templating, and something will probably not work here. Yeah, because we use variables that are not defined. So maybe let's get rid of the variables. And because this is a heat map, you need to know that a heat map requires that you will use a heat map format of the queue. And you have more or less what we had. We can then go to cell display. Unit is a time represented in seconds. And probably after refresh, or maybe it's not in the cell display, maybe it's in the Y, yeah, it's in the Y axis. So time, seconds, and here you have basically the same output that we've got in the dashboard we've been looking on. All of that clicking can be eventually turned into a JSON file. If we go back to our dashboard, I'm not sure if I have here an option to look to the code of the full dashboard. Yeah, JSON model. So that dashboard that you can see here, all of these graphs, etc., for Grafana is represented as this huge JSON file with all of the panels and setting for these panels. And that JSON file, in our case, is created from the JSON, which allows us to define reusable components. And for example, if I switch now to a different dashboard, let's give it a moment to load, which takes a while. We'll see if it will load. First two rows of that dashboard are exactly the same. Yeah, it loaded. So here you have exactly the same panels that were on the previous dashboard, because for the runner we have what we can see here, incident support dashboards. We recognize that there are some repeating patterns of runner incidents and they require looking on specific metrics. So we group that in few groups. But for each of them, we want to see saturation. We want to see the abdex value, a general view of how many jobs we are executing, what's the queue timing, what's the queue size. All of that is repeated on all of these 5 dashboards here. But below, we have things specific for, in this case, it's the database incident support. Using Jsonnet, using this project allows us to define a reusable component like this service abdex panel that we can then pull in dozens of dashboards and don't need to repeat the same JSON definition over and over again. So if someone wants to work in a bigger scale, then going through the hard time of learning Jsonnet, Grafana, learning how to like bind all of that together and feed Grafana with these dashboard definitions will definitely pay off in some time. But for those who just like to experiment with that and have any hints of how you can configure that, I think it's in the GitLab org group. Dashboards exports. Yeah, it's gitlab.com, GitLab org, Grafana dashboards. And this project, from what I remember, has a daily or hourly. Yeah, oh, I think it's the daily dump of all or some of our Grafana dashboards. So if you go to dashboards, in this huge list, maybe let's do CI, runners, incident support, runner manager. This one, the first we've looked. And this is the JSON file that you could copy. Go to your, let's do it. Let's, where is the row view? Here is the row view. So let's copy all of that. Let's go to Grafana and not new dashboard, but import dashboard. And here you can oh no, sorry. We would need to save that JSON file, and then here you can load that JSON file. And that will create a full dashboard from that JSON file. So by copying this and importing to Grafana, you can basically reproduce the dashboard that we have at this address. One thing is that there are some annotations. Annotation is something that you need to additionally configure in Grafana. This is a totally different story. I don't remember where on this list is the, I think it would be in the inputs or something like that, because you may have multiple metric sources for Grafana. Fortunately, for most of our dashboards, we are using a default input source. And in Grafana, we configured that to be our Thanos cluster. So if you load that JSON file into your Grafana and create a dashboard from that, the next thing you need to do is make sure that the default metric source in your Grafana is pointing to your Prometheus server, where you have metrics from Runner, from GitLab, from Workhorse, sometimes from node exporter on different nodes. Uh, Basically, if you want to use our dashboards as they are, you need to feed it with the metrics that it requires, or you will have just empty panels in some cases. But if it's just for the runner part, if you like don't care about many things like here, but you want to have this graph, or I'm sorry, you want to have this graph and this graph, and for example, these graphs, because this is all that you're interested in, you could like copy that JSON file. Then here I can go into edit because, like I said, these are created from code and they are marked for Grafana to not be editable. But if you create the dashboard by hand, even from the import, you can go to each panel, edit it, see how exactly it's created, what query it uses, what settings it uses. So you can learn in that way what metrics in what way we present to give a useful information for someone who manages the runner fleet and would like to know what's happening with these runners.
Wow. Hey, well, Tomas, this was eye-opening. I felt like I've learned like a whole year's worth of stuff in like the last hour. And for folks that are looking at this, please, give a shout out to Tomas for doing this for us. I'm going to upload the video to GitLab Unfiltered. It'll be public. So customers, if you're looking at this video and you find it helpful and you'd like us to cover additional topics in the future, please comment on the video and let us know. I might also maybe create an issue that we'll link to as well. But we definitely want to get your feedback because the goal of this is to give you the information that you need to manage your fleet. Tomas, this was brilliant. I didn't know coming in what we would cover, but this was beyond my expectations. Thank you so much for doing this.
I'm happy I could give you information that is useful. Like I said, all of that is hard when you look on it for the first time, especially when you need to learn Prometheus. Like Prometheus has a specific mindset, let's name it, behind how it handles metrics. Not for everyone, it's easy to understand from the beginning. When you start working with it, when you get used to it, it becomes very, very clear. And at least for me, it was very easy to work after a few weeks when I learned how to use it. Then same goes with Grafana. When you first time start using everything, it's like this panel, boxes, settings, all of that is very, very cryptic, and there is documentation for most of that, but like every time with documentation, you like read that and it's like, yeah, okay, I read that and now what to do. So the hard part is to start. Then because like I went through all of these stages. When we started working with Prometheus, I remember we had 2 or 3 engineers who've been members of the Prometheus project, and they worked for GitLab for a couple of years, and they like bring all of that to us. When we introduced first 2 metrics to the runner, I was like struggling with that concept for first few weeks. I couldn't understand why we are doing that in this way, because I was used to the monitoring systems like Zabbix, like CheckMK, where you have a different way of tracking metrics, or there were some systems where you were like pushing specific metric to the monitoring system and feeding it with some specific values. And here we have this metric exporting and collection, and why this is happening sometimes asynchronously, and then the specific way of naming metrics. I remember I was struggling for at least 2 years what to put into metric name and what exactly to put into the label. What makes sense to be part of a metric name, what makes sense as a label name and value. But once you start working with that more and more, it's become more natural. Then when we have these metrics, we had to like start looking on them. We started defining first alerting, because Prometheus is not only monitoring system, it's also alerting mechanism. There is a way to define alerting rules and alerting methods and routing between them, and it's a huge thing by itself. But we've been defining that by hand. Then we've got Grafana, how to connect Grafana with Prometheus, how to shape the dashboard. I remember the CI dashboard that we used before we migrated to this Jsonnet produced one had about 100 different panels. We like made the rows collapsed because like one day when I tried to load that panel, I was even not able to enter the edit page because it was like failing on load because there were so many things that it was trying to pull from the API from Grafana. And we wanted to decompose that, but decomposing that to multiple dashboards means I need to copy and paste panel definitions. And once I update something, I need to remember where to update that. And this was like stopping us from decomposing that huge dashboard, and within month it was less and less useful until someone showed me that, hey, we are using Jsonnet from a few months, maybe you want to like experiment with that and migrate the runner monitoring to that. So again, starting from scratch, learning how Jsonnet works, learning what's in the Grafana library, so Jsonnet library for Grafana, learning what's in a wrapper to that library because we already created some wrappers for the most commonly used panels that we have. How we define dashboards so that they look like they look and they are not editable and have some marking and linking to code, etc., etc. So first days it was like a black magic. Today I like when we got this new metric, it took me like maybe 20-30 minutes to update the definitions to like start using the new metric in a new way that we want. So this is very hard when you start, especially if you don't have experience with Prometheus and Grafana. If you know how Prometheus and Grafana works, then you know everything you need, because the runner part is just knowing what metrics there are. And sometimes to understand what the metric represents, you just need to go into the code to see how it's gathered, how it's collected, what information it presents, because sometimes it's hard to like put into description what exactly it is. And you like need to feel what part of the code it's in and what exactly it shows. But things like concurrent limit, jobs, version info, which is a static constant value, just showing what version information about the runner is. These are things that you just need to understand how they work and fit into your Prometheus and Grafana. If you don't know Prometheus and Grafana, there is a big work ahead of you, but that is something you just need to go through. And there is no magical solution here. Go through Prometheus docs, go through Grafana docs. If you are thinking about huge scale, definitely think about Thanos or maybe hosted Prometheus service in one of the cloud providers. But you need to learn this or understand these concepts to be able to get from our metrics, from Runner, from GitLab, all information that is possible to be gathered from there.
Awesome. Hey, well, Tomas, thanks again. I guess we'll be seeing you next time in one of these hour-long sessions. Talk to you soon. Bye-bye.
Okay. Bye.